Hey Honors Physics, Mr. Hausman here. One of the questions that came back as feedback from my D block class was, how do you know how to draw the free body diagram on a given charge? What direction are the forces? Is it a push or is it a pull? And how do we represent that? So the key variable or the key factor you need to look for is what are the signs of each of your charges? And I can see a negative sign for the 6, I can see a negative sign for the 12. Now, someone told me that my equal sign looks pretty trashy here. It doesn't clearly have a negative sign. Let's make this be positive. Okay, there's no clear sign, so we assume it's positive. Now, we know the fundamentals, right? A negative and a positive in close proximity to each other will attract, right? This is an attraction. And that sounds basic, but that's the fundamentals. Now, if you have two like charges, two negatives or two positives, they're of course going to repel. So what you do is you focus in on the charge in question. Now, it could have been Q1, Q2, or Q3. So what if we go to the Q2 charge right in the middle? What I'm going to do is I'm going to zoom in on it, and I'm going to say, okay, so what are the forces on Q2? So what you do is you ask yourself, and you literally kind of close it off. Don't even look at Q3. What does Q1 and Q2 do to each other? And the answer is a negative and a positive attract. So let's make an arrow that shows that they are attracting each other because that's a mutual attraction. They're pulling in toward each other. And we should label those forces accordingly. So this would be force 2, charge 2, pulling on charge 1. And this would be the force of 1 pulling on 2. Those are the same force. In fact, if you did the Coulomb's law between Q1 and Q2, you'd be finding the force, the 2 on 1 right here. And you'd be finding 1 on 2. That's why we actually say that Coulomb's law can only find the magnitude of the force, because do you see, one force is to the left and one force is to the right. Okay, so that's all we did was just think about 1 and 2. Now we're going to zoom over here and we're going to focus on what does 3 do to 2. And we're going to and have no thought about 1 now. And you can see that they also attract. But I'm going to choose to use a different color. This is force 3 on 2, and this is force 2 on 3. Okay, so let's zoom out now, and we can see now, do we have a complete free body diagram for charge 2? And the answer is yes, we've considered all of the possible forces that are on charge 2. And since that's what it's asking you to find, now what you would do is you would go in and you would calculate force 1, 2 using K, Q1, Q2 over the distance of separation between 1 and 2. You'd then do a separate calculation, force 3, 2, the K value constant, Q3, Q2 over the distance in that picture. Now, quick reminder, you would use the absolute value for all of your charges. You don't have to plug in the negative 12 microcoulombs, the negative 6 microcoulombs, but do remember that when you plug these in, you're going to have to represent them as 6 times 10 to the negative 6, then Q2 is 7 times 10 to the negative 6, right? We have to convert to coulombs because the unit for K is newtons meters squared per coulomb squared, right? That's the units for K. So that was the main question. Many of us can do the Coulomb's law calculations, but the question was, how do I get the free body diagram? Hope that helps.